Hi there, welcome back. Well, welcome back to something completely different again. I've said this before and I'll say it again. Sometimes it's good to be on a small island because although you don't have that much tube equipment, when someone has something to repair, there aren't that many people to do it. And therefore, it's actually good to be me. Well, this came to me from the owner of a project I'd done before. I'll link that above. It was the all-tube mic preamp, and that one was quite interesting because I'd never seen something like that before. I believe it was used in a radio station in the States at the time. And this one comes from the same owner, a friend of mine, and he is quite a fanatic about recording, home recording, and using really old equipment and original equipment. So what is this? Well, it's actually something quite interesting. This thing's got all these clamps, and pull the top off and we're left with this. It's called a Magnecorder and it's a model PT6V. And what this is actually just a preamp for a tape transport, an old tape transport. I'm not quite sure which year this is from, but it's pretty old. You can have record or playback. You would have your tape transport connected to this, your tape deck connected to this. So you can do record or playback. You've got your gain here, which would be presumably the record gain or playback gain. And then there's something called 7.5 or 15. Now that is actually the speed of the tape. The quicker the tape goes, the higher quality you would get. In other words, if you want high fidelity or higher fidelity, you would put it on a faster tape speed. If you want to record something without that much quality, but your tape lasts twice as long, it's 7.5. It's, what is it, inches per second? What is it? Anyway, it's the speed. And then you've got a monitor jack out, and there's an on-off switch that's, well, quite dead. If you take the back off, if we unclasp this, you'd get something like that. Now, I'm guessing that this is where the transport would be. So you would have your tape transport connected at the back, which I'll show you in a second, to your preamp. And then from your preamp, you've got an XLR output and a 600 ohm output that would go off to wherever it's supposed to go. The tape transport would obviously fit in this rack here. And when you put it all together, you've got a nice carry unit. Now this carry box is a little bit damaged. The clasps are completely rusted, but the owner's actually having a cabinet built for this, so he's not too worried about that. But let me show you what the back looks like, and I'll give you a closer look at this as well. So let's go handheld for a while. Let's see what we've got here. We've got our record and playback, our gain control, our tape speed, monitor, on-off switch. It's a PT6V. And it's got a record level or playback level indicator as well. Quite a cool one. And this thing is just unscrewed here. You take it off the rack. So obviously the tape transport would have screwed on exactly the same way at the top. But what I'm going to do is I'm going to take it off without trying to hold everything in place. I don't want to damage it in any way. I want to show you the insides. Just a quick view of the cabinet here. You see the rusted clamps are quite a problem. And otherwise, I think this could actually be restored. I think you can actually buy those clamps. You'd have to drill out the rivets, but I'm sure we could restore it. But he is planning to put this in a rack anyway. So let me get it out of here. So I've got it out of the cabinet, and it's actually quite small. Here's the front, and if we flip it around, this is what we've got. It's 115 volts. This is an American system, and he actually brought a transformer with him, the 230 to 120 or whatever. So I'll be able to use that. I'm not sure if this transformer can be converted. I don't think so. 2 amp fuse. That is what you'd connect to the recorder, the transport. So you'll have power going out of there. The audio in and out would go out of there. Then you've got your 600 ohm output balanced. A bridge in, which I'm not sure what it is till I see the schematic. And then we've got the two the recorder input and the microphone input as well. And if we look here, we've got all the tubes pretty well labeled, 12AU7, 12AX7. There's some pretty good transformers. Those transformers are really hen's teeth to get at nowadays, especially that one there. Here's another one. This thing is amazing. These transformers are very, very difficult to get hold of. So yeah, that'll be filter capacitors there. That tube, I think that's the rectifier tube. Yeah, I think that's it. Power transformer. And this whole thing doesn't look too bad. It's got to be cleaned and everything checked. But as far as I can see on this end, it's not been touched, which is good news. Let's look on the inside. Okay, let's see if our luck's held out. And no, it hasn't. Someone has been in here. I can see some pretty poor solder connections on here. These resistors have all been soldered in. Capacitors have not been changed. I'll give you a closer up look in a minute. The switch is just loose. That's not a problem. There's a selenium rectifier. Yeah, I recall it uses DC heaters, so this will be a 12.6 volts. Well, it'll rectify low DC voltage to give us 12.6 volt heaters. The switch is completely loose, but that's not a problem. Fuse holder. Everything looks sort of okay. I'm worried about some of these wires. They don't seem to be brittle, but all these solder connections have to be redone. Those resistors, these carbon comps, that looks like someone's really been in here. So that's going to have to all be checked. Fortunately, with the schematic, it should be quite easy. We've got our transformers on the bottom there. Those are transformers there. There. There's the other one. The capacitor's over there. Okay. Nothing too dramatic yet. And on this end, we've got a few more capacitors over here. These look original. That one looks original. One of the problems with these sometimes is the switch. The mechanism has to be properly cleaned. That's just a normal pot. There's another old switch. The thing about these switches is that they're high voltage. You can't just replace them with a normal wafer switch unless it's the right voltage rating. Yeah, that shouldn't be too hard. I think I'm going to have to remove this from the front panel, and that implies just taking these off. There are a couple of screws on here that connect that U chassis onto the front. I'm sure that'll all come out, and then I'll just have to disconnect the wires to the meter, to the VU meter over there. This looks pretty simple. There's some screws and nuts over here. So I think this whole thing will just move away from the front plate, and it should be fairly simple, says he, hopefully. All right, let me get this thing started. Let's see what we find. Well, I've removed the front, the faceplate. Nothing too difficult here. Just remove those nuts and bolts and the meter. But I then started with some basic checks, starting obviously from the power inlet. And I was getting rather optimistic about how easy this was going to be. And then as I measured the first resistor, it's open. So I decided I needed to look at this a bit more closely, because now I'm going to have to follow every single line through here. I probably would have had to do that anyway, but that resistor there, that's a 47k resistor that's actually connected to the recorder socket. I believe that just creates an input impedance or output impedance. I'm not even sure which. That thing is open. If that is open, and I'm sure that's had very, very little use. I mean, what is it? It's a signal line. So why would it open? I just don't know. It might be an indication of the type of resistors they've used in here. I see about 3 types anyway. So I'll need to go through this whole thing very, very meticulously and do some cleaning and everything else. But I decided before I did that, there were a few questions about the schematic that I wanted answered, and I thought it'd be a good opportunity just to do a little bit of analysis of what exactly this thing is doing. So we're going to get onto the schematic and figure out exactly what this thing does. Let's get on with it. Before I carry on, I just want to issue a quick warning. What follows is going to be either very interesting or extremely boring. It's the analysis of the schematic. So if you're not interested in that, I suggest you just fast forward to the end or accept my thank you for your company right now and don't waste your time going forward. If you enjoy that sort of thing, stay tuned and don't fall asleep. Here we have the schematic, and it's not too complicated. We've got the power supply here, the transformer. We've got that socket that goes off to the recorder. It's called the recorder multi-connector. That 47K there, that's the one that was open. But I had actually started following this, the power inlet line and so on. And so far what I found is that the transformers are fine. They're not open. There's continuity. The input one is, the primary is also fine, but the switch was not operating, and that just took a little bit of contact cleaner and lots of going backwards and forwards, and now it seems to be working. But I'll show you that when I do that on the device itself. But we have to look at this just carefully for a while. What we have here, it's 110 volts or 115, so it's an American system, and we go into the primary, and it also provides power to the device on the outside. So if we look at the AC line, really this is what we get. This is basically the supply to the primary of the transformer, and as you can see, it comes in from the plug. It carries on through to the switch, on-off switch, and then that switches on the power to the transformer itself. It comes back this way through the 2-amp fuse, but it also goes somewhere else, and that is it provides power to the recorder multi-connector like that. So the multi-connector here, the recorder, would also get the mains coming through the fuse, not through the switch. It's direct, so it would have to have an on-off switch itself, but it does have the fuse protecting it as well. Now, if we look at the secondary, we've got 3 secondaries here. The first one is this one over here, filament 3. What it does is it comes out of here into a bridge rectifier, which is a selenium rectifier, the one I showed you on the left there, that sort of tealish green. It then comes out and it goes through an adjustment, really a variable resistor, and you have to adjust it for 12.6 volts. So this is for the heaters, the 12AU7, the 12AT7, I think they are at the top there. They use 12 volt heaters, so 12.6 volt heaters. So these are now DC heater voltage supply. There's a 1000 microfarad capacitor here that smooths that. So we have our heater supply with a ground at the bottom. That ground, we will see in a second, becomes a common ground. But for now, that's what we've got. And we have a DC supply over here. This DC supply, as I said, is 12.6 volts. It goes to the tube 1 heaters, tube 2 heaters, and it doesn't seem to go anywhere else. Okay. Let's focus on the next filament. This filament, as we can see, goes to one place only. It seems to supply the heater for the rectifier tube, the 6X4. Now this rectifier tube, because it's got a separate heater filament, I presume this is about 6 volts, 6.3 volts probably. It's an AC supply, so it's not being shared, or it's not coming from this one down here. It's an AC supply, and it's indirectly heating the cathode of this rectifier tube. So this rectifier tube is not like some of the others that have a directly heated cathode. When you have a directly heated cathode, you literally have this whole winding raised to the output voltage level. So this is actually a bit safer, I think. But it also goes somewhere else. You can see it here. It goes to this point over here and that point over there. So what this is doing is it's providing a heater voltage, 6.3 volts, I presume. We'll just measure it later. I think that's what this thing is supposed to take. And it provides it to the recorder multi-connector as well, so that there's a supply for the recorder as well. Now, what happens here? Well, this over here is a simple rectifier. And what you get is this transformer, this filament, has a center tap. This center tap is actually grounded, as you can see, connecting to there. So we have a common ground over here. Our B plus, which is going to come out of here, is also referenced to the same ground as our heater supply of 12.6 volts. But then it goes off in the other direction. The other winding, the one winding, this is a dual supply. The one comes to the one anode and the other one comes to the other anode, like that. So we have, it says here, filament 1 or winding 1 is 300, 300 volts. So we've got 300 volts AC on there, reference to ground, 300 volt AC on here, so it's 300, 300. So this thing is providing a full wave rectification, which then has the DC, the rectified waveform, coming out of here on the cathode at 354 volts. Now that means, let's look at that, 300 times 1.4 is about 420. So this thing has got quite a big diode drop or voltage drop to give us 354. At this point, it meets the first filter capacitor, which is this guy over here. This is a half. Is it half? Or is it... Actually, I'm not even sure if it's half. 1, 2. This one is linked with that one. Yeah, this is half of a filter cap. One half is used over here, and the other half is used over here. Now there's... B plus is going somewhere else. Oh, I see what they've done. You've got your B plus coming out here. It meets the first filter capacitor. It then drops through a 2K resistor to there, and it drops through a 1.2K resistor to here. And we'll see where that goes next. The B plus coming out here, as I said, diverts to two directions, like that. It's filtered by that capacitor. Okay, let's follow that one along first. So that one comes through a 2K resistor. So basically you've got a filtered version here. There's another RC filter here, so a little bit more filtering happens, and you've got a bit of a voltage drop across that resistor, so 321 volts over here. Voltage drop obviously caused by the current that's going through that line over there. And if we look at where that's going, we'll take it to that point there. So once it gets that point, it obviously gets diverted to various directions, but we'll leave that for a second. Let's see what happens to this guy over here. This one comes out here, meets another filter cap to ground over here. It then goes to a switch, and this switch is record or playback. Now the way it's set is on record, so if it's going to record, the voltage, oh I see, that resistor was definitely getting high voltage. So on record, what happens is B plus is going through here. It's a bit lower because there's a voltage drop across here through the record playback switch, and it gets fed to the recorder multi-connector as a supply line, positive. And in this particular case, where is negative? Negative is here. So ground goes over here, and ground meets that guy there. So you have 0 volts and 300 and, well, what'll be 3, depending on the voltage drop across that, 300 and something. Okay, and then there's that resistor across there. That's the one that had burnt out, opened. So that is the supply line. Okay. What happens on playback? On playback, this is simply grounded. Why would they do that? Okay, we don't know what's happening at the other end of this connector. So on playback, there's no B plus over here. And they simply short this supply line to ground, effectively discharging this capacitor, but also really creating a current draw through that resistor. And I wonder why they do that. I know that this resistor would discharge that capacitor, but don't forget, it's still being fed by that B plus over here. So there's going to be a path to ground through 25K. If you've got about 354 volts, and you add this resistor to that resistor, 26K, that's quite a bit of current. What's that, 12 milliamps? I suppose not too much. But yeah, you'd definitely get a current path to ground through there. That resistor, I presume, is one of those big boys over there, because it will actually dissipate quite a bit of heat. Now if we follow the supply line over here, let's see what we've got. Our supply, B plus, comes through there. through this output transformer, and it goes to the anode of that tube. So this primary of this transformer, this is one of those coupling transformers. This is a 5-to-1. So effectively this is the load for that tube. That tube is the driver. And remember, this tube V2 is a dual triode. Okay, so you've got a preamplification stage and a driver stage. That makes sense. So that is driving that transformer. Then the supply also comes through here. Here we go. There to there. So that should have a capacitor. Yeah, it does. It's got another capacitor here. This one doesn't have a value, but I would presume it's probably about 20 microfarads, maybe 10 microfarads. It's also a filter capacitor, and it too is reference to ground, because if we take that ground over there and we follow it up, you see that this is also ground up to that point, in fact, and beyond. So the filter cap there, reference to ground, so it filters. There's basically another RC filter, so you get a more filtered version of the high voltage, which then has a 100K anode resistor, goes to the anode of that tube, and the signal will be coming out of here to that one. That makes sense. It then goes from this point here through that resistor, so that's another RC filter with that capacitor over there. It has two deviation points, one through that 100K anode resistor to there, and through that 100K resistor to there. So I think we've got our supply sorted out. This thing's been supplied high voltage through 100K anode resistor. This one also through 100K anode resistor. This one has a common filtering stage over here with this capacitor. This one has filter capacitor there, so it gets supplied through 100K resistor. Yeah, it all makes sense. They've all got 100K anode resistors, slightly different voltages because well, it'll depend on the position, whether it's this node or that node. There's a drop across those resistors, and it also depends on the anode resistors, which happen to be the same. But more importantly, it depends on how this tube is biased. Okay, that is our supply. I think we've basically got it all with the exception of some grounds, but our supply is done. Now what happens to the signal? If we follow the signal back, it's probably going to be easier. Here's our 600 ohm output. Now this is a signal output level. We've got this over here. So that would be, I think one is ground, yeah. So that would be the cold, for example, the cold signal. This one over here would be the hot signal, or the other way around actually, if we follow convention. So those are our two balanced output signals. This is our ground. And if we take this further back, we've basically got the signal coming from here. If the switch is on record, we get nothing on here. That makes sense. If the preamp is actually driving the microphone signal to feed it into the recorder, you wouldn't get anything out of this output, okay? You would get something, probably, I believe you'd get something over here. Yes, you would. We'll see that in a second. So this only works on playback. On playback, that would be down here. So we would get something like this. And yeah, that makes sense. That's coming from our output transformer. So on playback, when you want a signal to come out here, playback meaning it's playing the tape back. This thing is driving the signal. It comes out of the secondary, 1/5 the size or the amplitude of the primary. And it comes out here through there, comes out of the output over here. It turns this from single-ended to balanced. So that's it. That's basically it when we have a signal coming out. Let's go back and see what happens when we have a signal coming out. Well, there are a few more points over here. We're following this backwards. If the signal's coming out here, it's also going to here. And here we have various deviations. One of them is through this resistor, and it comes back to here. This is a feedback. So this is the negative feedback path to this triode, which is the pre-driver to the driver of the transformer. So negative feedback over here. It comes back regardless of whether the switch is on playback or record. And at the same time, whatever level signal you've got on here, whatever signal you have on here, you can take it out to your monitor, which would be headphones, with a 1.5K resistor just to reduce the level, and there's ground. So yeah, that's just a headphone socket. It also goes, this one is ground, remember. You then got a, this is basically a microammeter or milliammeter with the proper padding and attenuation to give you your signal level being read at the output of your transformer, of your secondary here. So that's always going to read the level, whether it's playback or record. Now let's just go back a bit further. We're still on playback. So what we have is we've got the signal coming out of here that's feeding the primary here is being fed into here. This is rather unusual that we're going backwards, but it doesn't make any difference. So the signal that comes off that is produced by this triode goes through that 15 nanofarad capacitor over here into the grid of that tube, of that triode. It's got a cathode resistor of 820 ohms and a cathode bypass capacitor of 25 microfarads. So this thing drives through there. That signal comes from that anode over there. And the signal that is produced over there, inverted, is the one that comes in at this grid over here, which comes from that tube over there. You see what we're doing? We're just going backwards. It's the same thing. And that signal there is the result of this signal coming in here, which has a level pot. So you set your volume level over here. It's referenced to ground. These are very simple triode amplifiers, nothing to them. The only thing that changes really is what grid resistor you use and what cathode resistor you use, and if you use a cathode bypass or not. This will set the bias condition. This one here sets the bias condition of the tube. So you got 820 ohm over here. It's obviously different to this one, which is 3.3K9, which in turn is different to this one, which is 1K5. How you set those depends on what sort of shaping you want of your signal, and I won't go into questioning how they came about it. This has got a pretty high grid resistor to ground. So yeah, okay. So whatever signal you've got in here is being amplified once, twice, 3 times. Also, it's being inverted once, inverted back, inverted again, and probably inverted on the other end as well. That's why when it comes back here, it's negative feedback, because the phase that you need here would be equal to that one actually, so that it's negative feedback to this tube. Okay, where are we? We're at the front here. We're nearly there. So if we take this signal here, this one, oh, okay, there's one more. Nearly forgot this guy. This guy is also amplifying whatever comes in here. We're still on, what are we on? Playback. Playback. Okay, playback means that this is over here, so it's actually bypassing this guy. Okay, let's have a look. If we're on playback, it means this thing is there. So the signal is actually feeding back to this point, playback to ground. If you're on record, that's bypass. Okay, so we've got a feedback signal through here. If you're on playback, what do we see? We've got the signal there through that capacitor. I'm not sure what value that is. If it's on playback, that would be in place. So therefore that would go to there. Now that's not quite ground, because that secondary is raised from ground through this 47K resistor. That's a 47K as well. I wonder why. Basically creating a higher reference. Not even sure why that's the case, but this signal is still coming in here, that signal there, to the same point. And what signal is that? If we're on playback, okay, yeah, if we're on playback, this here is ground. So that is ground. That transformer is grounded. And that goes to, okay, the cold, okay. And it's basically grounded. That one there comes there, comes there. This is on playback, so it's not seeing it at all. Let's see, where's the signal coming from? That's on playback, so that comes to there, that goes to there. That's on playback, so that comes to there. Okay, so playback, you've got the signal from the recorder, comes in here, goes into the primary of this transformer, referenced to, where is it? Referenced to ground. Yeah, playback is single-ended input, as you can see over here, because your 1 and your 3 are common. That goes to ground, so that's all ground over here. So playback, you've got single-ended input, a reference to ground, signal comes in, goes in here, goes through there, into the transformer. Transformer's referenced to ground, okay, that's fine. And then the signal is produced over here, raised from ground through that resistor. And it goes into there, but there's a feedback path from the output. I'm not quite sure what happens here. This is probably a configuration, pretty simple probably, that I can't recall. But yeah, that signal then gets fed in here. Okay, and your microphone comes in here, goes through there, and it goes nowhere because that switches in the opposite direction. Okay, so our playback is taking the signal, passing it all the way through to there. Okay, here we've got the other situation, which is the record situation. So let's see what happens with record. With record, what you've got is your signals coming in here. One is reference to ground. So your microphone signal comes in here, goes into there, goes to there. Now it feeds the transformer. It goes through the transformer into there. Now record means that this switch goes to there. So there's a different feedback arrangement here. This would be linked to there. So that resistor is shorted. Let's see, that's not there anymore. So your tube is getting driven here by this side. This side goes to there. It doesn't go anywhere. It goes to ground. Okay, so your microphone signal goes through that transformer, reference to ground, gets fed into the tube, comes out of the tube, goes to there, comes to there. Now you've got record on here. We've got record. That goes to there. So there's nothing coming back. Okay, fine. So it goes through there. Again, level control, through there, through there, through there. Same story. Everything gets out to the output, but now things change. Now you've got your signal coming out of your transformer, and it goes up there. Your level meter is still seeing the same thing. That meter still measures the output through there, through that line over here. But your signal, instead of going to your output, now comes back through there. And this is where we have that switch. There was the 7.5 inches per second and 15 inches per second. And it says filter unit. Now, why would this be relevant? Well, the faster the tape speed, the higher the quality you get through. But because these tapes, or these recorders, these tape decks, had a sort of pre-emphasis, just like you would have with a record player. You know, you have the RIAA curves and so on. You have a similar situation. So you would have some sort of pre-emphasis going on here. And this would be different depending on what tape speed you're using. So if it goes up through 7.5, it goes in here. There's a filter unit, which I haven't actually identified on here. I think it's a big block over there. I think it might not be a transformer. It might be the filter unit. It creates a pre-emphasis for that particular speed of tape, which then comes out of here and goes out that way. Or if it's 15, it just comes down, goes through there, goes through its relevant pre-emphasis and comes out of that end. So we'll just follow through as it is through here and comes out of this end, comes there, over here, and now we've got record. So that's there, there, there. And our system is recording rather than playing back. Okay, cool. So that there can either be the record in, or rather playback from your tape, or record in. It's a single connector. It's not like those DIN connectors where, you know, some wires were for the input and others were from the output. This bridge over here, what does this do? This bridges it to ground. I'm not even sure. I'm not quite sure what this thing does. So yeah, I don't know what that does. Maybe someone can give me a hint in the comments below. But I think that's basically what this thing does. We can see how it operates. And now it's a question of going through this whole thing, literally component by component, and checking everything and see where the problems may lie. I'm not going to power it up. The fact that I had one blown resistor right at the outset, well, yeah, I think it just it's a warning for me to take a bit more care. So that's what I'm going to do. I'm going to do the checking of components, see what arises, and report back to you when I have some news. I think this may be just a simple 2-video series, because I don't see that there's that much to get into here. It's actually a very simple system, unless we find something wrong with it, which I'm hoping we don't. If we do, you'll hear about it. But I'm hoping that in the second video, I'll be able to show you the results of all the checking and correcting and so on, and also be able to demonstrate, test this thing for you and for me. So I hope you enjoyed that. This is slightly different to the usual, but that's what I like to do. And I hope to see you back soon for video number 2 on the series. And in the meantime, thanks for watching. Bye for now, and stay safe.